Assalamualaikum warahmatullahi wabarakatuh. Okay everyone, today I'm going to discuss the networking model. There are 4 subtopics I will cover. 1. The concept of the networking model. 2. The TCP/IP model. 3. Encapsulation and decapsulation. And 4. The OSI layers model. Okay. Concept of networking model. A computer network refers to a group of computers that are connected to each other and can exchange data or share resources. So, are computer network and networking model the same thing? No, they're not. A networking model is a set of rules or standards that defines A networking model is a set of rules or standards that defines how computers can communicate with each other. In other words, a networking model serves as a guideline for the data exchange process between connected devices. This is how different vendors are able to communicate with each other by following an open standard networking model. Currently, there are 2 open standard networking models available. Okay, the TCP/IP model and the OSI model. Okay. Okay, next. Before networking existence of the open networking model, each company or vendor created its own proprietary networking model. For example, in 1974, IBM developed a system called System Network Architecture, or SNA. As a result, other vendors also create their own model. So, as a result, devices from different vendors could not communicate with each other because they use different sets of rules. After open networking model exists, our vendor adopt the same networking model, which is TCP/IP. This allows devices from different vendors to communicate easily with each other. Next, TCP/IP model. Nah, the TCP/IP model is one of the most commonly used type of networking models today. TCP/IP defines a set of protocols that allow computers, especially those of different networks, to communicate with each other. To make it easier to understand, every networking model is divided into smaller parts called layer. This layer. According to its documentation, the TCP/IP model consists of 4 layers, but in real-world implementation, it's often described as having 5 layers. In the original TCP model, the layers are network access, internet, transport, and application. But in the updated TCP/IP is divided into 5 layers: physical, data link, internet, transport, and application. Okay. Next, application layer. The application layer functional as the interface for application, managing how application access the network and create communication message. Example of service at this layer include HTTP, POP3, IMAP, SSH, and others. For example, HTTP is used when we access a web server. As shown in example image, a client using a web server a client using HTTP sends a request to the server. The server processes it and then sends back a response to the client. That's basically how it works. Next, transport layer. The transport layer provides service to the application layer and handles data transfer. There are two main protocols commonly used in this layer. TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. One of the key mechanisms provided by the transport layer, especially in TCP, is error recovery. In the example, a web browser uses TCP to send data to a web server, which then processes the data and sends back a response to the browser. Next, network layer. The network layer has one main protocol, IP, Internet Protocol. IP provides two essential features, addressing and routing. Both are important for managing connectivity and path selection. Each device on a network needs a unique address. For example, PCA has the IP address 192.168.1.1 and PCB has 192.168.1.2. Its address is unique, allowing devices to identify and communicate with each other. Addressing means assigning a name or address to each device in a computer network, while routing works like a post office, finding the faster route for data to reach its destination. Data link layer and physical layer. The data link layer defines the protocols required by the physical layer. One of its key features is FTS, Frame Check Sequence, an error detection mechanism that can detect errors but does not correct them. The addressing used at this layer in the MAC address. The physical layer, on the other hand, defines the physical cabling and connection between devices. What kind of cable or media are used to connect them so they can communicate? Next, encapsulation and decapsulation. Encapsulation is the process of wrapping data with headers at each layer, while decapsulation is the opposite process. For example, data from application layer is encapsulated and passed to the transport layer, which adds its own segment header, and so on. Each layer adds its own piece of information. This image. Next, OSI model concept. Today, the TCP/IP model is more commonly used because its protocols or structure are more widely adopted in real networks. However, the OSI model is still studied because it's easier to understand and provides a clearer conceptual structure. Before networking model existed, its vendors created their own model to ensure that devices from different vendors could communicate properly. The International Organization for Standardization (ISO) developed a universal standard in 1984 called the open system interconnection model, also known as the OSI 7-layer model. Okay, there are 7 layers in OSI model. Okay, 1. Application layer, 2. Presentation layer, 3. Session layer, and 4. Transport layer. Therefore, layers are often referred to as the upper layer, dealing with user interface, data formatting, and communication session. At 1 to 4. 5. Network layer, 6. Data link layer, and 7. Physical layer. These 3 layers are called the lower layer, which handle how data actually flows through the network. Okay. 1 to 4 is low layer. 5 to 7 is upper layer. Okay. Thank you. That concludes my brief explanation about